Writing formulas for Category 2 compounds is very similar to writing formulas for Category 1 compounds. In fact, you use the exact same steps. Start by writing symbols for the metal and the nonmetal, then determine the subscripts by checking the charges and making sure they equal each other out. Here's an example to watch. Manganese 2 iodide. The symbol for manganese, not to be confused with magnesium, is Mn. The symbol for iodine is I. Watch out for that capital letter I. It's easy to mix up lowercase l's and capital I's. Iodine symbol is I. Now we need to use the charges of each element to determine the subscripts. Normally we wouldn't know what the charge on manganese is because it's a green element. But since we already know the name, we have the Roman numeral. The Roman numeral here is telling us that the charge on manganese in this compound is positive 2. Well, that was easy. All we had to do was read the name. We can go back to the periodic table to find the charge for iodine. It's negative 1. Once we plug both charges in, we use the same process that we used for Category 1. Do the charges equal out? No. Positive 2 and negative 1 do not automatically equal each other out. So we need to determine the subscripts. Remember, we have two options. We can use the AX plus BY method, or we can use the crisscross method. I'll show both. Method 1, AX plus BY. Start with our equation, AX plus BY equals 0, and plug in the two charges, positive 2 for manganese and negative 1 for iodine. The LCM of 2 and 1 is 2, so we need to make sure that each part of the equation equals out to 2. Positive 2 for A times X and negative 2 for B times Y. To get 2 to stay 2, we need to multiply it by 1, so A has to be 1. To get 1 to become 2, we need to multiply it by 2, so B must be 2. There's our subscripts, 1 for the metal and 2 for the nonmetal. That gives us Mn1 and I2. Leave off the 1, that gives us Mni2. Here's the second method, the crisscross method. Take the charges and drag them down, crisscrossing them and ignoring the positive and negative signs. That gives us Mn1 and I2. Don't forget, charges and subscripts are different things. We don't need to reduce here, so our final answer is Mni2. Don't forget about the warnings we've mentioned before. Using either strategy, you should end up with Mni2 as your final chemical formula for manganese 2 iodide. Feeling confident? Here's some practice. Answers are up in just a minute. Here's your 3 answers, and here's some explanation of how you should have found them. Nickel and oxygen, Ni and O, have equal and opposite charges. Positive 2 for nickel here because of the Roman numeral in the given name, and negative 2 for oxygen from the periodic table. These charges automatically equal out, so no subscripts are needed. Next up, tin-4 selenide. Watch out for tin symbol. It's Sn, which looks nothing like its name. And selenide is one of those weird-sounding non-metal-ide names. It means selenium. Sn and Se are our elemental symbols, and we can find the charges in the Roman numeral for tin and on the periodic table for selenium. Tin-4 means tin with a positive 4 charge, and selenium always takes on a negative 2 charge. The LCM of 2 and 4 is 4. A lot of students get confused and try to use 8 here. Were you one of them? Don't go higher than you have to. It'll mess up your final subscripts. If we need both parts to equal 4, A must be 1 and B must be 2. So our subscripts are 1 for Sn and 2 for Se. That gives us SnSe2. Here's a warning. If you're using the crisscross method, this is exactly the kind of compound I've been trying to prepare you for. Here, when you crisscross, you get subscripts of 2 and 4. That's wrong. You have to reduce them to 1 and 2. So you end up with SnSe2. Here's an example with the highest Roman numeral you'll come across in our class, vanadium 5 nitride. V for vanadium and N for nitrogen. V has a charge of positive 5, and N always has a charge of negative 3. Whoa, the LCM here is 15, which means A must be equal to 3 and B must equal 5. That gives us V3N5. Still hanging in there? Review this video or others if you still have problems.